A 3.5-mile Robotaxi ride tonight costs several dollars per mile. Tesla claims by 2026 it'll drop to 20 cents. That's not improvement, that's a revolution. And if you're living on Social Security, watching transportation costs eat your budget, this matters. 3 questions nobody's answering. Why are rides expensive now, and what must happen to reach 20 cents? If production starts April 2026, when does it reach your town? And what technical barriers could stop this? I'll separate fact from assumption, no hype. You need truth about whether this promise is real or marketing. Understanding the autonomy gap. Tesla's full self-driving today is level 2. The driver is responsible, must pay attention, must be ready to take control. What Tesla aims for in 2026 is level 4, unsupervised autonomy, no human backup. The car takes full responsibility. That gap between level 2 and level 4 is everything. We're not talking incremental improvement. We're talking fundamental shift in how technology operates, how liability works, how cities regulate transportation. Why today's rides cost so much? 3 simple reasons explain current robotaxi pricing. First, small fleets mean crushing fixed costs. A few dozen vehicles can't spread maintenance, insurance, monitoring expenses across enough rides. It's like running a taxi company with 5 cabs instead of 500. Your overhead per ride kills you. Second, low uptime destroys profitability. These vehicles spend hours charging, cleaning, updating software, recovering from confused situations. A car working 12 hours instead of 20 generates half the revenue. Every idle hour loses money. Third, human supervision costs remain substantial. Waymo employs remote operators monitoring fleets, intervening when something unusual happens. Traffic lights fail, construction zones appear, cars need human confirmation. Those humans cost serious money. Until technology handles 99.9% of situations alone, those costs remain. Here's the critical insight. Cost per unit drops dramatically with scale. 20 cents per mile isn't possible today. It's a target requiring thousands of vehicles running nearly 24 hours daily with minimal human intervention. The question isn't whether 20 cents is theoretically possible. It's how long building that scale takes and whether technology can deliver required uptime. When does this reach your city? Tesla starts manufacturing April 2026. When does it arrive where you live? Depends entirely on location. Tier 1 cities come first. Stable weather, cooperative regulators, controlled traffic. Austin, Phoenix, Los Angeles. Technology works best there. Moderate temperatures, predictable rain, rare snow. Variables manageable. Tier 2 cities are middle ground. Occasional weather challenges, moderate regulatory complexity, some winter snow but not crippling. Local regulations require safety reviews but aren't hostile. These cities get robotaxis 12 to 18 months after Tier 1. Tier 3 cities are hard cases: Buffalo, Minneapolis, Boston. Heavy snow, dangerous ice, freezing rain, infrastructure not designed for autonomous vehicles. Regulators move slowly, demand extensive proof. Live here? 2 to 4 years minimum after production begins. Production is step 1. Robotaxis are deployment products. Building the car is easy. Getting regulatory approval, proving safety, scaling operations is where real work begins. Warm weather city with progressive regulators? Maybe late 2026. Harsh winters and cautious officials? Don't expect it before 2028. The Waymo Blackout reveals system limits. Early 2025, San Francisco power outage knocked out traffic lights.
Waymo vehicles treated dark intersections as four-way stops, correct programming. But the volume of intersections needing human confirmation overwhelmed remote teams. Cars sat waiting for approval. Traffic backed up. System couldn't scale to emergency. Not a car failure, a capacity failure. When hundreds of vehicles need human judgment simultaneously, you hit a bottleneck that exposes the critical question. How much human infrastructure does a robotaxi fleet need for rare but inevitable citywide disruptions? Tesla claims Cybercab continues operating during power outages without remote assistance, bold and unproven at scale. The real question? Trust a cautious, human-dependent system or a confident, unproven one? Both have risks, both have costs. A truly autonomous fleet must handle chaos, not just predictable traffic, but days when city infrastructure breaks down. Vision versus LiDAR. Which strategy wins? Tesla uses cameras. Waymo uses LiDAR, radar, cameras. Which is better? Here's honest truth neither company wants you hearing. LiDAR excels at geometry and positioning, measures distances with millimeter precision, generates detailed three-dimensional maps in real time. In dense traffic where 6 inches matters, that precision counts. But LiDAR systems cost $180,000 per Waymo vehicle, 5 times a consumer car cost. Building 10,000 vehicles, that's billions in difference. Tesla's vision-only approach uses 9 cameras, no LiDAR, no radar, just computer vision and AI. Dramatically lowers vehicle cost to $45,000, allows selling cars to consumers. Waymo wins on hardware capability today. Tesla's trying to win on data scale and replication speed tomorrow. Waymo vehicles are more capable in complex environments now. Tesla vehicles are cheaper, deployable in larger numbers later. Question isn't which technology is better, it's which strategy delivers safe, affordable service at citywide scale first. Right now, nobody knows.
Snow and ice, the northern problem. Live in northern United States? Wondering if Robotaxi handles winter? Short answer, not yet. Not reliably. Snow and ice change everything. Tire friction becomes unpredictable. Lane markings disappear under snow. Reflective surfaces confuse cameras. Driver behavior changes. People drive slower, more cautiously, less predictably. Autonomous system trained on California sunshine struggles in Minnesota blizzards. Robotaxi deployments start in warm cities always, not coincidence, operational logic. Prove technology in easy conditions before tackling hard ones. Phoenix before Detroit, Austin before Buffalo. Not cowardice, engineering discipline. Will robotaxis never work in snow? No, they'll work later, after software trains on millions of winter miles. Live in snow country? Manage expectations. Robotaxis arrive years after Sunbelt cities.
Cybercab design, why every detail determines cost. Purpose-built for autonomy means no steering wheel, no pedals, no driver's seat. Removes hundreds of parts, reduces weight, lowers manufacturing cost, simplifies maintenance. In continuously operating fleet vehicles, every pound and unnecessary component costs money over time. Weight reduction is obsessive. Cybercab weighs 3,000 to 3,200 pounds, 700 to 900 pounds lighter than Model 3. How? Gigacasting. Front and rear structures cast as single pieces instead of welding hundreds of parts. Fewer parts mean fewer welds, fewer failures, faster assembly, dramatically lower maintenance costs. Body panels are polyurethane plastic, not steel or aluminum. Lighter, corrosion-resistant, durable against impacts. Robotaxis get bumped and scraped daily in city traffic. Steel dense and requires expensive bodywork. Aluminum dense and costs even more to repair. Plastic flexes under impact and returns to shape. Over 5 years, that saves thousands per vehicle in bodywork. Single-motor rear-wheel drive. Not dual motor, not all-wheel. One motor. For performance cars, that's compromise. For robotaxis, it's optimal. Lighter, cheaper, simpler, easier maintenance. Cybercab doesn't need 0 to 60 in 3 seconds, needs reliability and efficiency in stop-and-go traffic. Battery under 50 kilowatt-hours delivers 200 to 250 miles range. For urban robotaxis, that's sufficient. Most rides under 10 miles. Vehicle charges during downtime. Smaller batteries cost less, weigh less, charge faster. Combined with 5.5 miles per kilowatt-hour efficiency, significantly better than Model Y, results in exceptionally low energy cost per mile. This efficiency foundations Musk's 20-cent claim. Energy at 15 cents per kilowatt-hour, vehicle achieving 5.5 miles per kilowatt-hour, energy alone costs under 3 cents per mile. Add maintenance, insurance, and depreciation, and 20 cents becomes plausible if uptime is high and fleet scale large. Interior is extreme minimalism. 2 seats, no rear bench, no massive screen, no luxury trim. Not arbitrary cost-cutting, alignment with function. Robotaxis need durability, easy cleaning, comfort for short trips. Fewer components mean lower manufacturing cost, fewer failures, faster turnaround between rides. Tesla announced cleaning fees, $50 for moderate messes, $150 for severe cases like vomiting or smoking. Not punitive, operational discipline that protects vehicle condition and controls costs. Every design decision reinforces one goal: low cost per mile through efficiency, durability, scale. If technology works, this design redefines urban transportation. If not, expensive experiment. But certain is this isn't luxury car pretending to be taxi. It's purpose-built machine designed to operate profitably at 20 cents per mile.
The legal maze. Law is harder than technology. Hardest truth about robotaxis? Technology is easy part. Law is hard part. Many states and cities require human controls. Steering wheels, pedals, licensed drivers ready to take over. Cybercab has none, makes it illegal in many jurisdictions, regardless of how well technology works. Tesla's deployment path depends on winning regulatory approval in dozens of cities and states, each with different rules, timelines, political environments. Places like California and Texas are relatively friendly to autonomous testing. Others, like New York and Massachusetts, move cautiously, demand extensive proof before allowing driverless operation. This is the bottleneck everyone underestimates. Build perfect autonomous vehicle, but if regulators won't let you operate, you have expensive paperweight. Tesla isn't just racing to perfect AI, it's racing to change laws, city by city, state by state. A slow, grinding process that doesn't respect product launch timelines.
The insurance question nobody's answering. Here's something that should worry you more than technology or regulations: insurance liability. When a robotaxi causes an accident, who pays? The passenger? The fleet operator? Tesla. Traditional auto insurance assumes a human driver makes decisions and bears responsibility. Remove the human, that entire liability framework collapses. Insurance companies are still figuring out how to price risk for vehicles with no human control. Early estimates suggest robotaxi insurance could cost $2,000 to $10,000 per vehicle annually. Spread across enough miles, that's manageable,
But in early deployments with smaller fleets and lower utilization, insurance alone could add 20 to 40 cents per mile to operating costs. That's the entire margin Tesla claims to have. The real breakthrough won't come from better sensors or smarter AI. It'll come when insurance actuaries have enough data to accurately price autonomous vehicle risk. And that data doesn't exist yet. Every mile driven by Cybercab and Model Y robotaxis feeds that database. Every accident, every near miss, every successful trip builds the statistical foundation insurers need to offer affordable coverage. This is why Tesla's billions of real-world driving miles matter beyond just training AI. It's building the safety record that makes insurance affordable. Waymo operates in controlled geofenced areas with limited conditions. Tesla is betting on proving safety across diverse environments, weather conditions, traffic patterns. Riskier approach short-term, but potentially lower insurance costs long-term if data proves safety.
What happens when the system fails? Every technology fails eventually. Your phone crashes, your computer freezes, your GPS gives wrong directions. When a personal car's technology fails, you take manual control. When a robotaxi with no steering wheel fails, what happens? Tesla's answer is over-the-air updates and redundant systems. Multiple cameras, multiple computers, multiple communication channels. If one fails, others take over. Sounds good in theory, but theory and practice diverge in unexpected ways. A software bug affecting one vehicle is manageable. A bug affecting entire fleets simultaneously is crisis. In 2023, a bad software update briefly disabled some Tesla functions. Owners could still drive manually. But in a robotaxi fleet with no manual controls, a bad update could ground hundreds of vehicles instantly. Lost revenue, stranded passengers, damaged reputation, potential safety incidents. This is why fleet operators will likely be extremely conservative with software updates, deploying them only after extensive testing. That conservatism conflicts with Tesla's traditional approach of rapid iteration and frequent updates. The tension between moving fast and maintaining fleet reliability will define how quickly technology improves versus scales. And then mundane failures, flat tire, dead battery, vandalism, mechanical failure. Every traditional taxi has a driver who can assess situation and call for help. A robotaxi needs sophisticated AI to recognize problems and logistics to dispatch roadside assistance. More complexity, more cost, more failure points.
Model Y, the fleet strategy everyone overlooks. Everyone focuses on Cybercab, but Tesla's robotaxi strategy starts with Model Y. Why? Model Y is proven. Millions on roads, billions of miles driven, known reliability, known maintenance costs, known operational behavior. Model Y handles 3 or more passengers and significant cargo. Cybercab optimized for 1 to 2 passengers and light cargo. Together, they cover full spectrum of urban mobility. Family airport trip, Model Y. Solo grocery run, Cybercab. Different tools for different jobs. Refreshed Juniper Model Y includes incremental improvements mattering for fleet operation. 4% better aerodynamic efficiency translates directly to lower energy costs. Quieter cabin with double-pane glass reduces passenger complaints. Improved seat comfort increases satisfaction and repeat usage. Better climate control reduces energy consumption while maintaining comfort. Tesla kept traditional turn signal stock in Model Y despite removing from other models. Why? Operational clarity and intuitive controls matter, especially in transitional autonomy phases where human drivers occasionally take control. Signal that Tesla subordinates design ideology to functional reliability when real money is on the line.
Model Y isn't replaced by Cybercab, it's complemented. One handles versatility, other handles volume. Together, they form fleet architecture, serving diverse customer needs while optimizing cost per mile.
Can 20 cents per mile actually happen? Truth in 3 tiers, no sugarcoating. Tier 1. Yes, 20 to 40 cents per mile is achievable in easy cities with large fleets and high uptime. Deploy 2,000 Cybercabs in Austin, operate them 20 hours daily, achieve 95% uptime, maintain low energy and maintenance costs. The math works. Price drops to 20 cents and still generates profit. Tier 2. In difficult cities with snow, complex regulations, infrastructure challenges, it takes longer, maybe 2 to 4 years longer. Technology needs more data. Regulations need more negotiation. Costs stay higher until scale arrives. 40 to 60 cents per mile is more realistic in these markets for first few years. Tier 3. If Tesla can't achieve high uptime, can't scale fleet size, can't manage maintenance costs, price won't drop to 20 cents, stays closer to current Robotaxi pricing, $1 to $3 per mile. At that price, Robotaxis remain niche service, not mass market transportation solution. Real answer? 20 cents per mile isn't guarantee. It's goal depending on execution, scale, regulation, technology maturity. Possible, not certain. Anyone selling certainty is selling something. Final insight that matters most. Cybercab doesn't need beating Uber on price immediately. Needs beating Uber on one thing: stable costs as scale increases. Traditional taxis and rideshare have driver costs scaling linearly. Double fleet, double labor costs. Autonomous vehicles have fixed costs scaling logarithmically. Double fleet, per mile costs drop. That's real competitive advantage. Not cheapest ride today, but cheapest ride at citywide scale tomorrow.
My question for you: if robotaxis drop below $1 per mile and operate reliably in your city, would you give up your personal vehicle? Would you trust a car with no steering wheel? Or is there something about owning your own car, controlling your own transportation, that no cost savings can replace? Drop your answer in comments and tell me, what's the biggest barrier to robotaxis succeeding? AI technology? Snow and ice? Legal regulations? Something else? I read every comment. Your insights shape videos I make next. If this video gave you clarity on whether 20-cent promise is real or fantasy, hit subscribe right now. We're building a community wanting truth about Tesla and electric vehicles, not hype. No clickbait, no fanboy nonsense, just honest analysis from someone covering this industry for 2 decades. In 2 days, I'm releasing Deep Dive on Tesla Model 2, an affordable electric car that could make EVs accessible to working-class Americans. Under $25,000, over 300 miles range, a timeline that might surprise you. If Cybercab transforms cities, Model 2 transforms car ownership. Turn on notifications, hit like if this helped, share with anyone skeptical about autonomous vehicles. Let's have honest conversation about what's possible, what's probable, what's pure speculation. Thanks for watching. See you in 2 days with Model 2 Breakdown. Stay curious, stay skeptical. Don't believe everything you read on the internet. Goodbye.